Awesome, mic check. All right, we're good to go. Hello everyone. Welcome to the Army's panel on the future of power. My name is Dr. Stephen Williams from the United States Army's DEVCOM C5ISR Center. The center has been instrumental in developing novel technology such as IR cameras, GPS systems, and also the AA battery form factor. Now the center sets its eyes on tackling power and energy while addressing the increasing need for sustainable, reliable, and accessible alternatives. I'm joined today by three experts in power and energy sector, Ms. Cassandra Riley, Dr. Thomas Zawodzinski, and Mr. Eric South. Our discussion will focus on the challenges facing the energy storage and conversion market and how technologies developed by the Army may play a role in our nation's power and energy future. Just so everyone knows, we'll be sure to save some time at the end of the discussion in case you guys have any questions, but do feel free to come up to either of the mics. There's a mic in the middle of the room, there's a mic right at the front of the room if you have any questions during our discussion. And now I would like to ask you guys to join our panelists, or welcome our panelists. So we'll go ahead and do some introductions. Ms. Cassandra Riley, if you wouldn't mind introducing yourself.
Sure. Good afternoon. I am Cassandra Riley. I am currently a program manager for mobile electric power. So my office is responsible for providing all of the DoD, not just the Army, their tactical generators. So generators that they're going to take out into the field. We don't do infrastructure. And then my team specifically does the small and medium, so anything 60 kilowatt and below. And I will make that a little bit more palatable when we get to my portion to understand kind of what that means for the Army and for you. But yeah, I'm excited. I've got about almost 12 years with the Army. Started in power. I've done a couple things, and I'm back here in power again. So thank you.
Dr. Z.
Hi, Tom Zawodzinski. I'm a Governor's Chair professor at the University of Tennessee, Knoxville, with a joint appointment at Oak Ridge National Lab. I've got about 35 or so years in starting from really basic molecular electrochemistry, leading up to work on devices in batteries, fuel cells, and all sorts of variants in between, plus spin-offs. And so I guess I'm addressing many of the, sort of underpinnings and technical holes that I see out there. I want to warn you that I sometimes will come off pretty pessimistic about certain things, but I like to use the term skeptical optimist when I'm describing it because, you know, when you know where all the warts are, you kind of basically get a little bit jaded with, you know, the press release society we have.
Thank you, Dr. Z. And Mr. Eric South.
Thank you. Well, good afternoon, everyone. My name is Eric South, and we're here at the South by Southwest Conference. So thanks for coming out to the conference that's named after my family. Just kidding, but thanks for that laugh. It makes us feel good up here. They've told us that we only have an hour and that we're under the gun to keep it under an hour. They've actually got a clock up here. It's not working. We might want to turn that on.
We might go over a little bit now.
But
I thought we had an ongoing hour.
My name is Eric South, and I am a naval employee at the Naval Surface Warfare Center in Crane, Indiana. But I live in Fredericksburg, Virginia, do a lot of work with the Army, and am directly supporting the industrial base policy battery sector within the Office of Secretary of Defense. I've got about 20 years of government service, most of which has been with the operational energy and battery community. Eric South, thanks folks, and we'll chat some more later.
Thanks, Eric, I appreciate that. So in the Army, there's several efforts underway to cut essentially our greenhouse gas emissions in half by 2030 and then reach essentially net zero greenhouse gas emissions by 2050. So these efforts are done in terms of internal combustion engines, fuel cells, batteries, solar, wind, and nuclear. But there are some large steps in order to kind of meet that target in a holistic manner, not just speaking in regards to, yeah, cool, we cut it by 50 and then of course 100, but the secondary and trinary efforts associated. And so with internal combustion engines, they require fossil fuel that lead to significant greenhouse gas emissions. Batteries have environmental impacts associated with their production, operation, and post-production or end-of-life disposal methods. And so that kind of really decreases the sustainability for those systems. Fuel cells and electrolyzers struggle by way of high-cost materials relative to conventional methods of internal combustion engines or reformation. And they also endure significant durability problems as well. Solar and wind, intermittent, variable, so impact their reliability. And each of these technologies requires essentially a logistic chain in order to operate, whether that be an actual fuel or Mother Nature itself, making them only accessible in niche locations. So it's interesting that we can go ahead and define the problems that exist within these fields. But if we can define the problem, there should easily be a solution to these problems. So,
You would think that.
you would think that. But Dr. Z, if you wouldn't mind kind of opening the discussion and sharing some of your thoughts associated with these challenges that we do face in regards to actually moving towards the future and kind of addressing these issues.
Sure. Very quickly, I want to mention a couple people from the past who unfortunately within the last month have passed away. A local person, if semi-local, he's from New York City originally, but UT professor Alan Bard was one of the greats in our field of electrochemistry, and then a great guy to interact with, and then another great guy to interact with from kind of the opposite end of the spectrum that passed away is one of the sort of unsung heroes in commercialization of lithium batteries, a gentleman named Ralph Broad. To have two of those guys pass within 2 weeks was kind of a surprise. So batteries, let's start with something you all know. There's a lot of different types of batteries, right? There's the batteries in your cell phone, the batteries here, there, everywhere, and everybody's talking about a better battery. First, we're stuck with where we are, in the universe, and we only have essentially certain elements, and lithium is pretty much one end of that spectrum. How you use the lithium is what improvements can be made on, but in fact, every time you try to have something that's more and more higher and higher energy content, you're going to end up with perhaps questions about safety. So I like to think of two types of batteries or power systems. One is the classic battery. It's a contained system. Lithium-ion batteries and so on are like that. The other is what I'll call an open system. A fuel cell is one extreme of an open system, whereas there's intermediate things, so-called flow batteries, which are often talked about for the grid, and metal air batteries, which have only one side open, essentially, that are kind of hybrid in those. Lots of talk about lots of different types of batteries. So you've heard about lithium-ion a lot because it's in your consumer devices like crazy and was adapted frankly, by taking a lot of consumer batteries and taping them together at first and put into cars, and it worked, amazingly enough. You still have the residual questions about fires, and that comes directly from the chemistry. In fact, you might hear about lithium batteries, sodium batteries, magnesium batteries. Pretty much those are all metals that'll start on fire under the right conditions.
Great to carry around in our pockets.
Exactly. I have a friend who lost it in a backpack. You know him too, yep. Fernando. Yeah. But basically, so this is why you occasionally get fires. But it's usually not the metal that is the problem in a lithium battery. Lithium forms sort of a protective coating over it. I've taken pellets of lithium and dropped them into water, which then all they do is kind of fizz like a really bad Alka-Seltzer. But things like sodium or magnesium don't have this protective coating and get very, very much more active. So that's kind of one starting point. And on the other end, I mentioned fuel cells, you have hydrogen. That's intrinsically an aqueous, that is water-based technology. We can't help our occasional nerd speak. But the aqueous technologies are inherently safer, but give you less access to energy in the battery. So zinc is another one that comes up commonly. But thinking about fuel cells, we talked about this earlier, behave like an engine rather than a battery. You have to put fuel in. And all the ancillary stuff that's in the engine compartment of your car is also there for a fuel cell. So that's kind of the scope. There's a substantial amount of effort across the board in commercializing these things. But the key thing is the answer to the question, why are there so many batteries? Because there's so many applications, and lots of them are different. And one of the things I think we want to get at is how you sort of connect them and hybridize.
It's fair. No, I appreciate that, Dr. Z. I know, Eric, within the operational energy space, some of the concerns that Dr. Z kind of brought up are kind of present. Is it fair to assume that, work within the industrial-based policy, really impacts the proliferation of some of the technologies that Dr. Z brought up, such as batteries?
It's a fantastic question. I'm going to focus in on a few words I've heard you say. I've heard you say holistic, I've heard you say industrial base, and I've heard you say proliferation, right? So when I was a young Marine back in the 1900s, if you can believe it, my backpack was only about 50 pounds. Now, the backpack is closer to 150 pounds. Why is that? A lot of it has to do with this battery proliferation. We started this conversation off about all of the various technologies that you've heard my colleagues speak about. And when we speak about the battlefield, when we speak about the troop, we often will have all of these DoD offices building their own device to do their own section of the battlefield capability. But we don't design those systems as a holistic system. So at the end of the day, Sergeant South gets just a bunch of stuff that gets thrown in his backpack, and we have a unique battery for each of those unique systems. I remember when I was first getting started with my career, trying to come up with a personal power system. We actually got that in front of Popular Mechanics back in 2014. They threw us a great big shindig and everything. But this idea of a personal power system enables the individual to sustain his self with storage and generation and control of power. To do that, we had to first understand what was the individual's load. So we needed to start with data. Data, which, as you can imagine, on the battlefield is often hard to come by. Time out from the war, folks. If you'll just bear with me, I've got to put this little data logger on you. Okay, time back in. That really doesn't happen. What we found was that there were multiple instances of the same piece of equipment. Think of a radio that you would get one from McDonald's and one from Burger King. It's the same thing. Often it used the same electrical parameters. One was green, one was black. One had 3 nubs, or 3 pins. The other had 3 nubs. There was a difference of 1 millimeter. 1 millimeter meant that that battery was not standard. I could not swap it. I had to have a unique battery for that system, a unique battery charger, a unique battery supply chain, all for the same capability that you would find Burger King and McDonald's. That is what we are trying to move away from in the battlefield of the 21st century. Starting with data as much as we can get, understanding how the interoperability between all of the various forms of energy, batteries, hydrogen, generators, fuel, solar, wind, the whole kit and caboodle, how does it all fit together on the battlefield? In lieu of having that next energy source, which is going to win somebody a Nobel Prize, probably not me. I've tried, and I just couldn't get the math to come out right.
Maybe someone in this room.
Maybe someone in this room.
That's fair.
Nobel Prize, hey, let me know how your math came out. But in lieu of that next generation energy source, To increase resilience and sustainability, especially on the battlefield, we have to treat the whole system as holistic right from the start. From an industrial base perspective, we need to make sure that when we are giving critical minerals like lithium to our warfighter, that we have strong domestic sources for that production. Even though the DoD is a relatively small demand signal from a larger industry, we have to make sure that our industrial base has domestic strength. Part of what we're doing at the OSD battery sector, working to promote battery standardization across the Department of Defense, and helping to ensure our industrial partners have the necessary resources to domestically produce what we need. So I don't know if that's kind of what you were wanting, but I'll be quiet for just a little bit and turn it back over to our moderator.
No, I appreciate that, Eric. No, I think that was great, highlighting the aspect associated with the large proliferation of non-standardized batteries, the challenges associated with our soldiers and not being able to actually have that, interoperability. That doesn't just exist in the Army, that exists outside of the Army as well, right? And it kind of leans over to what, Cassandra works on when it comes down to generator sets. And so at the large scale, we talk batteries, which, lean to the lower power aspect. When you start talking about generator sets, you're talking kilowatts at that point, and microgrids associated. Mm-hmm. But I struggled to understand a little bit more. I get that there's the commercial aspects associated with how we can go and develop generators, and it's kind of fed into what large industries kind of led to. But in the Army, there has to be a difference in terms of the requirements or in terms of some of the challenges, right, that you face. So could you provide some clarity associated with, how you go about facing the problems regarding larger power?
Yeah, absolutely. So Eric and Dr. Z both mentioned batteries, which I think we're all very familiar with. When I started working and I knew I was going to work in the battery lab, I thought, I know batteries, right? AA's, AAA's, got the little watch cell batteries, right?
You get batteries from Walmart, right?
Exactly. And Army batteries are so different, right? We have all these requirements. But I would say in terms of the larger scale power and energy, I think you can make the argument that the Army doesn't have its own problems with power and energy. I think I'm also going to try and dispel that as I continue talking. I think we have similar problems to the commercial sector with unique Army challenges. And that's what we work after. So we've talked about standardization, which is something that the Army is working on now with batteries. But we've kind of gotten after that already with generators. So I mentioned in my intro that my office provides all of the DoD's generators. So we have a standardization requirement across. So when a new program comes on, they have to come to us, and if we can't meet what they need, then we sign a little waiver, and they can get something else, right, off the economy. So I think some of the challenges we see with generators and power and energy, and I want to compare it to something that's a little bit more palatable, because I have to imagine in the audience today, we don't have a ton of soldiers or Marines, which typically are the users of our systems. If we do, great. I am not one of them. We've got some great guys up here that have that experience. I've got 2 doctorates next to me. I'm not either of those things. So when I was preparing for this today, I was kind of thinking, what when we think of Army generation on the battlefield, right? Because we've used the word battlefield, we've talked about sergeants. How does that relate to the commercial sector and what's really of use? And so I was doing a little research on South by Southwest, and I know later next week, I think there's a 4-day concert series out at Lady Bird Lake. So there's concerts going on before that, and they're in buildings with energy that's plugged into the grid, right? So when we talk about grids, microgrids, traditionally our homes, our businesses, our buildings are run off of the grid. When the Army talks about microgrids, which there are several different kinds, but we typically focus on what the commercial sector would consider off-grid microgrids. And those are going to be the systems, the generators and parts that you employ when you don't have a hard stand infrastructure to plug into. So think of probably the generators that they're going to set up at Lady Bird Lake probably over the weekend, if they're not already set up now. You're going to have to power amps, equipment, lighting, sound, monitors, I don't know, cotton candy machine, is that something that'll probably be out there? And so when you look at that in terms of what energy needs, you have the time to set up, you have the space to set up. If something goes down, if a system goes down, you can call up Home Depot and they can run you out a new generator. It might be a little small, it might be a little big, but you don't really care because you only need it for a couple days. You're not concerned about whether or not you're running at low efficiency. If you run out of fuel, you can go down to the gas station and get some more. So these problems do come up that the Army sees, but at least in my very innocuous situation of a music festival, they're not something that's going to have any sort of lasting effects. You're not super concerned about security, loss of life. Those are still things that we think about. You may have air-conditioned tents, green rooms for performers, for attendees, those all running on generators. And so when we take that and we look at the challenges that the Army faces, when you're going to take a generator out into the field, right, when we go deploy somewhere, whether it be in the mountains, in the desert, outside of a town, those needs are still there, but there's a little bit more cause and effect that's going to be there, right? You're worried about security. You're worried about the time that you're spending setting up is time that you're not spending doing other things that are more relevant to the mission. Here, you may still run into that, right? So you may have a short time to set up for a concert or music festival, but at the end of the day, you're probably only wasting a little bit of time. You might get some grumbles for starting later. You're not worried about whether or not you have to get, a squad into position to pull security, whether or not you're going to run out of fuel. And so what the Army's worked on, and one thing that is applicable to industry and the commercial sector in general is the fact of microgrids. And one of the recent standards that was published is called the Tactical Microgrid Standard. And so that is a communication protocol that allows separate systems to talk to each other to essentially form a microgrid using separate pieces. So you're not rolling into one place with one system that now has to power everything, right? You're not reliant. You can decentralize it a little bit, and that gives you a lot more flexibility. And so the Army's working on this so that when they deploy and they get all their equipment in, they're going to be running off of their batteries and their vehicles until they get their power infrastructure set up. So the Tactical Microgrid Standard allows for each of those systems. Again, it's really just a communication protocol. It's how the systems would talk to each other. You don't really have to add any hardware. You don't even really have to have a separate controller, because within that language that you've created, or you can create, you can add that controller aspect to one or more of the systems so that they can talk. So what does that really mean to the layman, or to myself, who is, again, not a soldier or Marine or a doctor? To me, that means that I can run my systems with a little bit more intelligence. So I don't have to worry about trying to start them and stop them on time. They can talk to each other and they can balance the load. I don't have to worry about this tent or this generator going down because it's getting too much of a draw on it, because it can pull from another generator and those systems can work together to get after it. The opposite end of that is when you use a generator or the engine inside and you're using it well below its threshold. So that creates a lot of inefficiency and you're losing fuel. You may think, well, I'm not running it that much. I have a very light load on it. What's the effect? Well, the effect is that you're essentially getting a lot of waste fuel and you're going to run out of fuel earlier than you want to. So the Tactical Microgrid Standard, which again was published, I believe, last spring, and it started as an Army standard, but the commercial sector is looking to it. Even though it says tactical, it does not have to only be tactical. You can use it for anything. Allows to have that intelligence so that we can take the time and energy and mental load and capacity out of figuring out how these all should work together, put them into the systems, create that smartness and build up their intelligence so that we can start relying on them for their efficiency and their reliability, so that we don't have to and we can spend time focused on other things. If that's pulling security for a unit that's going to do a reconnaissance mission, great, that's awesome for the Army. And if it's setting up for a music festival so that people can get in earlier and you can start selling food and drinks and get a little more revenue, get some more audience participation, then that's also great.
I appreciate that. That was
thank you.
excellent. No, I appreciate the correlation to what's required in terms of setup in regards to operational theater, and relaying that actually back to use case, right? What you kind of mentioned in regards to the Tactical Microgrid Standard is the application space for it to be transitioned to the commercial sector. Mm-hmm. And I think a lot of the technologies that we do work on can be transitioned to the commercial sector. And I've always wondered, kind of, if we were to take Army technologies and were to frame out like a sustainable, reliable, and accessible environment or power and energy ecosystem, what would that look like, and how do we start? And I'll just hold that for an open-ended question for the panel.
Well, so I think that, we focus, I know Cassandra, we focus the day-to-day on that tactical, but as Cassandra mentioned, some of the things that the services do develop are transitionable to industry. I think GPS and the internet might have started out with defense-based priorities, but are now all over the place. One of the challenges that we have in the Defense Department with the standards that Cassandra spoke about, we have a different set of rules that will be applicable on the battlefield versus at that music festival. The tactical microgrid standard is going to enable us to sustain ourselves longer on less fuel. The battlefield of the 21st century is going to be contested in terms of resources. So this microgrid at the tactical level is in fact going to allow us to not have to do as many resupplies, which if you look back to the early 2000s, and even in the recent wars with Ukraine, fuel convoys and logistics are a large target for the adversary. So increasing that fuel resistance is something that TMS is in fact going to help promote on the battlefield. And as we develop those robust standards, allowing industry to take a look at what we've done, just like with GPS, is something that is going to perhaps yield benefits that we have yet to fully realize in the commercial market.
So essentially leveraging the tactical microgrid standard, employing that in terms of policy relative to our grids, lowering the fuel usage associated that's being consumed to reduce basically greenhouse gas emission is one way that we could leverage the technology.
Yeah, and I think adding on to that too, so I think what TMS also allows to do is it lets you take different building blocks and network them together to build a more efficient system. So you could have energy storage in the form of a few batteries or several, right? That's something that I think is coming out in industry more and more. You could have renewables like solar. You could have different generators. Your vehicle can be part of it as well. Depending, I know, I'm not going to say I've done it, but I know some people tailgate and use a lot of their vehicle power to do things, to have fun, have some lights going, music going, things like that.
Right, essentially, as long as that energy system component, whether it's generation or control or storage or load, as long as it has that sort of TMS software on it. Think of a USB. A USB is a great example of a standard. As long as you have USB connection, you can plug in and stuff will talk and power will share. So even beyond the tactical, employing a standard similar to TMS would be a great way to do tailgating and all sorts of things that would be of interest to commercial.
Yes. So thinking further down and thinking down to the device level, these devices, I mentioned fuel cells, I mentioned batteries, they behave radically differently. And so they can operate on longer or shorter timescales and so part of the standard has to be through this communication to essentially take advantage of the strengths of these things. And
synchronizing the holistic, right?
Oh, spicy.
Yeah, but in fact, that's in layman's terms, perhaps, making everybody talk to each other and get along. Now, different missions, of course, I would assume are going to have rather radically different types of power profiles that need to come on. And in fact, there's also it's got to come on fast aspect of things that you have to do. And I don't think right now commercially, these sorts of things are thought of in that holistic way. You have a whole suite of different types of things being developed, all with their own hype. But in fact, I'll give the example of a fuel cell and hydrogen, which is often counterposed to a battery. A fuel cell is never going to exist on its own. It is basically always going to be a hybrid system. Again, think of it like an engine. And it basically produces power when you feed it fuel. There's a battery in your car. And in fact, nowadays with hybridized systems, there's a battery that's doing a lot of things like taking power from regenerative braking, that all goes to system efficiency. And I think the microgrid concept, sort of looking at that hybridization structure at the sort of device level can really take advantage of it.
No, I like that. So the interesting thing that I heard is essentially take advantage of the time domain by stratifying capabilities, enabling an opportunity for us to achieve higher efficiencies relative to the multitude of different technologies that can be developed. Is kind of the summary of what I've got from all three of you guys.
I think that's way better said than what we said.
Yeah.
But yes.
I appreciate it. So I had another question, specifically in regards to policy. My work is significantly on hydrogen fuel cells, but the Army has focused its efforts and operated under a single fuel forward policy since 1990. And it aligns well for the Air Force and the Navy because they consume a significant amount of JP8. And they're working on efforts to reduce greenhouse gas emissions by utilizing S8. But I had the question associated with if the opportunity space for ground operations leads to flexibility, right? Mm-hmm. And so not imposing any direction, but saying, what's the viable path forward or do you think moving forward with S8, or do you think moving forward with alternatives gives us a better advantage in the future?
I think it's alternatives, of course. Ultimately, everything comes back to electrons. We talk about fuels and so on and so forth, but the ultimate unit of exchange is electrons. We could talk about hydrogen, we can talk about methanol that you could generate locally, we could talk about fuels and reformers and so on, but all of those things eventually come back to electrons in this case, or electricity generated by the availability of those things. So in fact, we do in the end have a single fuel that when you electrify, and so
sorry, I didn't mean to interrupt you,
No,
Tom,
interrupt,
but
please.
You said everything comes to electrons at the end of the day, and I mean, if you're talking about combustion, electrons where?
Well,
right?
okay. I'm thinking about
specifically to the alternatives. Understood. I apologize.
No.
Oh, okay. Fair.
So within the Beltway, that's where the Pentagon is. Within the Beltway, we are keenly aware of how policy drives the way that the DoD will acquisition. We are also keenly aware that the dependency on fossil fuels is a tether that often limits us in terms of dynamic capability. However, we're also very much aware that there's a very fragile trade space between alternative sources and fuels versus our traditional systems. Taking alternative energy in a small system like a radio is very different than trying to fly an airplane or an aircraft carrier that utilizes alternative energy. So we are developing war games and models and simulations to allow us to analyze that trade space between combat performance and the source of energy that we go after. But we're definitely very aware of the need to explore other energy sources.
So if we're to look at other energy sources, I mean, in my work, I find there's a lot of gaps that exist in regards to the technology that's available to utilize those energy sources in various applications. So that implies that there has to be essentially a drive for the market to shift one way or the other, or technical development employed or done by essentially the Defense Department. But if the market was to shift, where do you think the market needs to shift to, right, in order to enable the proliferation of alternative power and energy storage capabilities?
I think I might have a very controversial answer to that. I don't know if I want to share it, but I feel like I can trust you guys. So I personally think that the shift that needs to happen in commercial industry is the shift to longevity of systems. I think when we look at a lot of our electronics components, it's all very consumer oriented, they're consumable, right? And so I talked earlier, I said the Army didn't have any of its own unique problems, which is a total lie. But you believed it when I said it, so I'll keep going with that, right? No, so I think some of the challenges that the Army does have is when we look at developing any system, but we're talking about power and energy, we have a lot of factors that play into what we need them to do and how we need them to operate.
Absolutely.
And so if I were to go to REI and buy a solar panel, I'm expecting to use that for, I don't know, a couple years, and like if it breaks, I'll just buy a new one. But that's not the way that the Army works, or really any of the DoD, because we build systems to work in a broad range of environments. We want them to work in hot and in cold. Sometimes we'll have tweaks, but usually we want them to be reliable. We also often employ systems, especially our larger systems, for decades, right? So the office I support, our generators, I mean, the generators that are out there are older than I am. I'm not going to say what that is, but right? So, and I think the shift I would like to see in industry is that we look at having these systems that do operate for years on years so that we're not just having all of this waste. Because I think that relationship with being able to build a more robust, reliable system for the normal consumer would translate very well over to the DoD and the applications that we see there.
But I think the commercial sector, at least in grid storage, is coming there.
Sure, I would love that.
Definitely. We're talking for either grid storage or actually large fuel cell systems like trucks, 20,000, 25,000 hours, and then also years. Starts to translate to 20 years that people want something like a flow battery to be on the grid. Sumitomo has already tested one for 10 years of a particular chemistry. But actually, from my perspective, one thing that's really lacking is the sort of detailed scientific and technical basis that can get you there. So I've recently had the experience of being on a panel that responded to some executives that were developing a flow battery chemistry, in fact, and they did everything as well, took care of all the problems that others have had in the field, but it was going to take them several years to get get it into the field because they needed to test for those lifetime things. But there's no understanding of how to do a faster or accelerated test to sort of do that. There's little understanding of how to de-risk that by understanding the science that's really behind it. It's just sort of a big gap that sits there. You have sort of demonstration and sort of what you guys would call 6-1,
development,
6-0 and 6-1 level work, if you will.
Essentially proving the theory.
Exactly. I mean, the sort of, again, understanding of how to assess the likely longevity of a new device is just not there.
That's fair. No, it ties right into what I wrote next. Wow. So
look at that.
Yeah, so the interesting thing is you guys talk about essentially reliability, right? But Z, you kind of hit the nail on the head when you're talking about there needs to be work done at the fundamental level in order to address the problem. Cassandra, you really highlighted the reliability aspect associated. What I find is that, especially when emerging technologies are under development, right? Or a startup starts, saying this is the problem that we're going to solve. When it becomes too niche, there's essentially that line of could I end up in that valley of death, right? Associated with a startup. But I know that the Army and the Department of Defense have a lot of collaborations when it comes down to startups and when it comes down to industrial partners and universities as well. So I wanted to ask if you guys had any positive experience where there was a very niche application or niche technology that was coming on the market that the support from the government kind of helped bring that technology to the forefront, or bring that technology to a place where it could solve some of our power and energy needs?
No, it's all negative. No, actually, we've done a few different things that have involved the Army in particular. Recently, we've done some work on some metal air batteries, and basically without the support from the Army, and frankly, constant feedback and encouragement on a real-time basis, we wouldn't have been able to sort of advance as quickly as we have in making something that's kind of state-of-the-art now for that particular battery type. And furthermore, I've worked with plenty of companies, small companies by SBIRs and STTRs and other mechanisms that also have that interplay. There's actually a very beneficial interplay, I find, between small companies for sure, and the Army because of that. So we have a colleague that we've known, and he's got a small company that actually has a contract, and they're talking about ways of doing recycling and sustainable work in the fuel cell sector, for example. And again, you can't do these things in a vacuum. It sounds great. We're going to recycle a fuel cell. Well, really, okay, what does that mean? How has it been used?
How do you transition it to someone that's actually going to use that
recycle it to
technology?
what? Ultimately, do you want to maintain the structure, the fundamental structure? Are you just looking at the high value catalyst that's in there or whatnot? And then basically the collaboration, as it turns out, with the program offices of the Army has really helped in that respect.
Awesome.
Transitioning those niche technologies are sometimes very challenging for the DoD, and for a host of reasons. When industry develops a system, their goal is a lot of times profit. When the DoD fields a system, the objective isn't profit, the objective is combat capability. Mm-hmm. So a lot of times industry will develop a niche technology which is very interesting for a small section of the commercial market, and it works very well for that small application. But when you take it and want to apply it to that battlefield, especially over the very complex course of our DoD life cycle, and of course when it's literally getting shot at, changing a small part of that niche application to harden it for battlefield operations completely changes the form factor, and it loses its integrity as a product and is no longer viable. So for a host of reasons, transitioning those niche technologies are very challenging.
Sandra, did you have any
I
technologies
do. I have one. So one of the batteries that I talked about earlier that was so foreign to me when I started working for the government is the conformal wearable battery. It's about the size of a sheet of paper. It's about yay thick. And it is meant to flex because it's meant to be worn on body armor or somewhere on a soldier's body, which is not something that a normal consumer of batteries is going to need. I'm sure there may be an application somewhere out there. But that was something that the Army decided, how can we have a larger battery that has longer runtime, but is still safe? So Eric talked about getting shot at. I specifically, a couple years ago, was responsible for trying to determine how to test a battery for gunshots and shrapnel and do it consistently and yada, yada, yada. But when we talk about bringing technologies kind of from innovation
That's a Seinfeld
to
reference, folks. Yada, yada, yada. Seinfeld reference.
When we talk about transitioning technologies that are innovative, so the one thing with that battery is it is the safest lithium battery out there. And so a lot of the technology that went into the inner workings of the battery so that it can get shot at, and then get wet, it can get blown up, it can get shrapnel, but it still doesn't catch on fire because, I don't know, if I just got shot at, I don't want to have to worry about catching on fire afterwards. I don't know about you.
That would be at Burning Man.
There you go. So that's something where that application was a little bit more innovative. Industry wasn't looking at it too much. I think they were looking at on the small scale for electronics and things like that. But they hadn't put so many of these cells together to make a larger battery, which makes a larger fire or makes a larger boom. And so a lot of those applications were innovative at the time and now have been implemented in a lot of the vehicles that we have and larger form factors that really, I think, kind of started with the Army pulling it out of just that single cell, single battery look and transitioning into something that was larger and can be more applied elsewhere. And I mean, we've seen that since.
Fair. And I know, Eric, you mentioned in the previous statement associated with that need for a centralized power, right? Or that power production, right? So I know there's also the work that's also been done with fuel cells in that regard too. Mm-hmm. And so I know there's benefits of being able to actually have small scale portable power developed by fuel cells and utilizing common fuels to basically actually support those battery needs, right? So
Are you demoing that later in Southwest?
I am demoing it.
Just by chance.
Yeah, just by chance, right? I am demoing it basically all next week over at 800 Congress. And then also when it comes down to the standardization aspect, we're also going ahead and demonstrating the small tactical universal battery as well at 800 Congress. So solving the problem associated with proliferation of multiple different batteries, tying it into one single family of batteries that all have the same interface to resolve that gap associated with various batteries being out there. So awesome.
So if I can just throw in a amusing comment.
Of course.
One of the differences between battlefield and the lab in terms of fuel cells, I learned working on things vaguely related to chemical warfare agents. Anything that poisons you will poison a fuel cell. So you also, in fact, the battlefield environment is very harsh for fuel cells.
When I first got started in this field, my task was to determine if a Marine would be better served with carrying a bag full of spare batteries or a wearable fuel cell. Now, this was back in 2008, and things have changed a little bit, but the answer quickly became no. Fuel cell on the back of a Marine in combat is not necessarily the ideal thing. The Marines in this field experiment just took the thing off, left it next to the tree, and continued on their way. So a great example of this would be fuel cells for a hiker who is hiking the Appalachian Trail. Fuel cells may be beneficial in that scenario, but the minute you put it on the back of a troop and have them in a combat situation, that niche application changes.
Different meaning to the fog of war.
Fair. Now, I'm looking at the time here. I know we have a little bit of time left. So I just wanted to make sure I go ahead and open it up to the audience, save some space for you all. So if you guys have any questions, again, there's a mic in the middle of the room and then one at the front of the room for anyone that wants to come and ask.
Oh, we got someone.
It looked like she was faking her way past the mic.
Sorry for being that low.
No worries.
That'll work.
The question would be, the evolving situation in Ukraine and the Middle East, and how drones have affected everything. I wonder if how that's affected your thinking in terms of power generation.
We work on so-called eVTOLs or drones, electric vertical takeoff and landing types of systems, and in fact, they're very energy intensive, and there's going to be a lot of drones in the future. We can't meet that with just lithium batteries. Yeah. So that's one thing to keep
Well, I think too, are you asking more about like the threat to power and energy?
Exactly.
Yeah, so Eric mentioned earlier the word contested. So contested logistics is an office or a team that was just stood up. So when we talk about microgrids especially, because I think batteries you're not as worried about, one of the bonuses to that is like decentralizing. Instead of having one big generator for everything, right, now you're at risk. If that goes down, you're screwed. Now you could have several different generators, and so if one goes down, you'll still be all right. So we are, I think decentralization is a big component of what we're looking at doing to just provide flexibility, provide security, and give you that redundancy without having to have redundant systems.
Everything that we've talked about today goes at the answer to that question. Standardization, UAV type 1, UAV type 2, UAV type 3, so forth and so on. We can't have all the different proliferation of batteries that we have to take care of, right? Decentralization of components that Cassandra talked about. Alternative sources of energy, data, the holistic synchronization of the holistic, all the way down to those individual components is key. And we have agencies who are looking at that problem as we speak. Some of which we might not be able to talk about necessarily in this venue.
Well, when I talked about the contested logistics team that just got set up, power and energy is one of their priorities for that exact reason. So you're spot on.
That was a great question. Yeah. I see another one. And if a line forms, just please form the queue, and we'll make sure we get. Thank you. We'll go with the one in the front, and then we'll head to you afterwards, if that's okay.
Thank you. My question is to Dr. Z. On batteries for electrical cars. So you mentioned at the beginning of the session many kinds of technologies like lithium, sodium. Yes. What do you believe is going to be the future of batteries for the electric car, considering that so for cars to get more and more popular, it needs to get cheaper and safe, right?
Yeah, and I think that's actually the crux of things. have been particularly skeptical about batteries for cars coming from Buffalo, New York. That's a little bit colder than California or whatnot. Basically, cold does really bad things to range. And in fact, the other side of that range story that people talk about is that it takes just as long to charge up, basically, even though you have much less range. But that said, they're a fact. Right? We had a snowpocalypse for Knoxville of 10 inches of snow, and we got cold for a couple weeks, and my colleague talked about his Ford F-150, but that's a $125,000 vehicle, and I think that's actually the crux of the matter is ultimately the cost, right? What's happened is all the early adopters and so on have jumped quickly onto the electric vehicles. And all that great stuff. We have people have their Teslas and their Nissan Leafs or whatever it's going to be, and in the meantime, the average guy, it's a problem, right?
But do you think, I guess to rephrase this young man's question, specifically in regards to the future of the battery, right? What chemistry, what technology?
Oh, okay. If I go to that, I mean, there's really good stuff out there. I would say now with silicon-based electrodes and also solid lithium types of system. And some of those systems are actually, especially the solid-state lithium, is quite a bit safer than, because it just simply doesn't have the volatile components, which are usually what causes the fires.
Thank you.
Yeah.
In the back? So my question, I might have to come up to the front. We can get that.
Make you work for it.
We appreciate it, yes.
Okay, so my question is around the power draw of machine learning algorithms, and perhaps in the future an over-reliance on the machine learning algorithms to make the decisions at the local Ford operating base. And so losing power could severely handicap their ability to think. And so what considerations are being made for the large-scale power delivery for machine learning models?
Cassandra, you want to answer that one?
Yeah, so I think there's really two sides of that I see happening now. So, I've worked with a couple wearable systems where we're increasing a lot of the power draw. And so what does that look like? What kind of systems do we have? And really speak to that redundancy. And I think that is something that the Army does really well, is provide redundancy in some form, whether it's a built-in battery that you're trickle charging off of something else so that you're not having to have your system completely go down. So I think applications that we already have, as that power draw grows, will grow with it. And then the flip side of that as well is something that we've had to keep an eye on is I'm not going to say limiting. Trying to limit or trying to bound what that power draw is, right? Because you can't just keep being a power sucker if you don't have the power generator.
There you go.
Power sucker.
Yeah. So it is something that we have in mind, and I think there's a lot of integration that the Army needs to do between different offices so that we are keeping that in the forefront.
Yeah, instead of plugging in your car, you could plug in your soldier.
Hey,
you might.
Awesome. Yes, sir.
So I come from the world of industrial technologies, whether it's like oil and gas fields and that kind of stuff. And while consumer tech, to your point, may have more niche and has more of a profit motive, big industrial facilities and companies have a profit motive, but they do have a lot of the motives around energy consumption, reliability, and are built to last, and even fleet management as well. So I'm curious at what type of overlap you've seen with big industrial companies and what collaborations may have been fruitful from there, whether power generation, power plants, or otherwise.
I like that you threw fleet management in there. That is something that I do focus on in my office. So So Cummins Power Generation, I think they are speaking in the next panel. Is that
Correct. Right after this, there's a panel called Driving Innovation associated with the Ground Vehicles Center associated with DEVCOM. So they'll be talking a little bit about electrification of vehicles. It would be a good time for that.
Yeah, so they're...
Yeah, I guess fleet management, I'd also like, in the context of, say, oil and gas, be like, hey, we've got a field of oil derricks and that kind of thing. So it could be, in your case, perhaps a fleet of distributed generators and that kind of thing. So.
Yes. Well, so the reason I brought up Cummins is for the office that I work at, they're like the provider for our biggest fleet of generators. And so a lot of our efforts that we've partnered on with them are because they're interested in as well for their own applications. So especially when we talk about the Tactical Microgrid Standard, TMS, that was something that we did not, we pushed without funding because it was the right thing to do. They put in their own dollars to develop because they said, hey, if the Army helps us get this going, right, because we want it, we need someone to help us do it. If they get that going, then that will not only help us, but help them. So I would say, I think for some of the larger systems, that's not really the area that we work in. That's more kind of, I think, like the installation level. And Eric, you may have experience in that.
Right, yeah, so what I was going to say is our careers have been on that operational side of the house, the tip of the spear, the last mile. There are agencies, installations and logistics, who have efforts and experience looking at the bleed over between industry and our DoD installations. I will say that the office I have been supporting has an effort with MIT Lincoln Labs to look at the energy storage based electrification of installations. And I was at MIT Monday talking to them about that effort. So it's something that we're working on, but I think, at least from Cassandra and my perspective, our expertise is more on that operational side.
Yeah, but talking to the fleet management, so I think one thing that is unique to the Army as well is we don't always have dedicated personnel to do certain things, right? So larger generators, some of them have certain military specialists that can do that, but a lot of them don't. And so a lot of the discussions that we're having with some systems that use generators or some of the units is like, hey, we don't have guys to run this. So how can we keep that in mind and take some of the intelligence, some of that planning out? And so when we talk about predictive logistics and managing our footprint, I think that speaks to some of the fleet management issues that you're seeing as well.
Same exact issues we deal with these.
Yeah.
Same exact.
Are you going to be at our reception later today?
I might be.
All right, well
All right,
then, yeah,
30
let's talk
minutes
more
after
about that then.
Yeah.
Yeah, thank
Awesome.
you.
Thank you.
Awesome. I think we have time for one more question if anyone had any. All righty then.
One closing remark, it's an oldie but a goodie. We have 2 minutes. You matter. Until you multiply yourself by the square of the speed of light, and then you energy.
Oh my goodness.
Ouch.
I didn't know where that was going.
I appreciate that, Eric. So, wanted to close with, so if you're interested in learning a little bit more about ways to interact or collaborate with the Army, there's a lot of talks that are going to be held by the Army's Application Lab over in the Capitol Factory. So tomorrow, know that there's going to be a panel discussion titled Think Big, Start Small, the Army's Bottom-Up Innovation Revolution. It's going to be moderated by Ms. Kimberly Newton, and our director, Mr. Welsh, is actually going to be on that panel as well. So that'd be a great opportunity to go and actually further discuss, some of the opportunities to collaborate with the Army. Again, 5 o'clock to 6:30. We're actually going to be right out here holding a reception in case you had any additional conversations or questions that you wanted to hold with the panel. There's a lot of wealth that's on the stage between these three individuals. And lastly,
And yourself. Don't knock yourself.
I appreciate that, Cassandra and Tom. But lastly, I want to thank you guys all for your attendance, and I look forward to seeing you guys at 1700. Thanks again.
Yeah, thank you.